All right, so welcome to your second day of programming. We'll be a little bit more involved than it was on the first day. First day, we just kind of covered the creation of certain variables and stuff. Today, we'll actually be doing method creation, operators, and other built-in data types, which I kind of spoiled on the first day because I already went over the float. But we'll be using it more in depth for today. So just a quick review. We have these different types of statements. There's assignment, which is actually assigning a value to one of our variables. There's declaration, which basically just says, hey, we will be using this variable at some point, but doesn't set it to anything. And we went over a simple method call for debug.log and passing in a string variable. So the computers need the variables to actually store data in them. The equals operator assigns a value. The plus operator has two functions, simple algebraic adding or concatenation, which is actually putting two strings together. So let's jump into creating a method. Well, start and update were already methods that were already put into the code for us by Unity. But there are actually 4 parts to a method, particular in their declaration. So difference between a method declaration and a call. For declaration, you're just saying what that method will do. Method call is actually using that method. For the syntax of actually declaring a method, you first have a return type. Then you have an identifier, which is synonymous with name, so like the name of the function. Then in parentheses, you have what is called a parameter list. These are things that you can actually pass into the function if it needs certain data or things like that. And then you finally have a code block, which actually defines what that block of, or what that function will do when it's called. So let's go open up Visual Studio and take a look at that start and update function. So I'm going to open up that October lectures project that I made. All right. So I have that game object with that lecture 1 script attached. And anytime I open a project, I always want to just press play right as soon as it opens to make sure it's where I left off and everything was saved, just so there's no issues. And I see we have all those outputs from that last time. Excellent. For this one, we're actually going to create another script. So we can right-click in our assets folder, create a new C# script, and this one will be simply named lecture_2. All right, now let's open that up. Okay, so just like when we first created lecture 1, we see that it's got the same name as the actual file name, and it's got these start and update functions inside of it. So these are actually function declaration, or function declarations. Start obviously is the identifier for this function. These have a return type of void, meaning they don't return anything. We'll talk about that a little bit more later on once we start creating our own functions. The parameter list, which is inside these parentheses, is empty, meaning it takes no data in, and that return type is void, so it just takes in no information and returns no information. It is just going to be called and run whatever is inside the code block. So I can actually open up the lecture 1 just to as a reminder of how this was working. So lecture 1, for its start, was actually running all this code as soon as the game started. Unity by default will call start. It'll actually call this method when it first starts up for initialization purposes. Then it'll also call update every single frame. So let's actually create our own method that we want to do. Instead of putting just information, all the stuff we wanted to do in here, like if we take a look back at lecture 1, we have a bunch of outputs. There was even an addition, and then another output. Lots of different things going on in there. Well, let's create a method down at the bottom that will actually add and print two things together just by calling that method. So we're going to have a void return type because it's just going to execute. It doesn't need to return any data back to the user. And since we want it to add and print, we'll simply name it add and print. Then we need to start a parameter list. Well, if I want to add two values together, I will need two parameters passed in. I'm going to need two integers passed in. So let's do an int, and the names you give these integers in here will just be used for inside of the function. So let's say this int a, and then to add another parameter, you can just add a comma, and int b. And we need to actually define our function with a body. So right now it's not doing anything. Well, if we're going to be adding these two values together and then printing that, we're going to need that debug.log to print, and we want to do a plus b. And that with a semicolon. So I've created this function, or declared this function, but I'm not using it anywhere. Let's see what happens when we jump back to Unity. And right now, when we press play, we see all of our lecture 1 script still running and everything. To switch what script is actually active, for one thing, I need to actually make sure to assign this lecture 2 script to that game object, or to a game object in the scene, so that it knows to run. I can also just click this little checkbox to turn off that lecture 1 script. So now when we run, we see no outputs. That makes sense because I'm never doing any of the actual outputs. Even though I have debug log in this function itself is never called. So if I wanted to call this function, I need to use the function name, so add and print, and I see it popped up there and tells me that it takes in two parameters right here. So add and print, and I do need what is called an argument list. So parameters match with the actual function declaration, and arguments match the method calls. So I need to pass in two integer values. Well, let's say 2 and then comma 3. So I'll go ahead and save this. jump back to Unity, and check out what that's outputting. Well, that's 5. So our add and print function is now working.
You don't have to put like an add sign in between them. They know to do that because of
the add sign is down here. Right? If we take a look at how this function is actually, or how this is actually running,
right,
I can do what is called active debugging. If I click over in this lighter gray area, I can put a breakpoint on the line of code that I want to pause at. I then have to attach it to Unity by pressing the play and attach to Unity button. And we'll see that the window's kind of changed and everything. That lets me know it's fully attached. We jump over to Unity, and if I press play, we see that it popped up in Visual Studio and now has this little yellow line to tell me what line of code it's currently trying to execute. And then I can use these other buttons right here for stepping into, stepping over, or stepping out of certain different things. Step into, if there's a method call on that line, it'll actually go to that method declaration and show you how that's working. So that's exactly what I want. So boom, I was up here and it jumped me down to here because I'm actually calling this method on that line. Step over is just going to go to the next line of code in the current script level. So I do step over, and I see right here it's doing that debug log A plus B. So that's where that addition is actually happening.
Okay, I see.
I press step over again, and I see we're at the end of that actual function body. I go up here, and because it was the end, it returned off of that line and is now at the end of this function body because this is the actual function that gets called from the start of the game. So after I can press play to actually go back to Unity and everything, because Unity will seem like it's frozen while you're debugging because you're actually pausing its execution. So you have to press continue, and Unity returns back. We see that it did actually output that 5 there, and everything is fine and dandy. So, because I'm done debugging, I want to actually stop this debugging so that it's no longer attached. And I'll try and show you more of active debugging quite a bit so that you guys can track down different logic problems and see how the actual code is executing. So, let's jump back here, and right here we see that it's got that method name of add and print. Yeah. And takes in the 2 parameters. This one is a little bit more involved. It's got the sum of A and B, outputting the actual values, and then actually doing the addition later. So this is important because, remember, once again, it's just outputting that 5. Well, that doesn't tell us a whole lot of information from inside Unity. So I can add a label, just like how we were adding the labels to the other ones. The sum of, and then just output the value of A, and then add a plus sign inside those quotes. Plus B and one more quote equals, and then we need to output our added value. So if I do A plus, I don't know why it did that, that was weird, must have fat fingered it. A plus B here, just like we were originally outputting. Why is it not like that? Give me a second. So it's going to complain because I'm not, because I forgot a plus sign right there. I forgot that it wasn't properly working. So we have our a plus b, just like we had originally in our equation, right at the very end of that. Let's see what happens if we try and print this. If I press play, I see the sum of 2 plus 3 equals 23. Well, that's pretty wrong. That's the reason because of order of operations. When we were just outputting the a plus b, that was just actually adding those two ints. Right now it thinks that this plus operator, which even just hovering over it, I can see it's adding two strings together. So that's the concatenation operator, even though it's not clear. I want the addition to happen before it adds that string on to the end. So I have to add parentheses. You guys remember being taught like PEMDAS and yep. So it's similar, very similar to that. There's a couple of intricacies that we'll go over once we cover more operators. So we'll save that now that that's in parentheses. And whoops, jump back to Unity. Now when we press play, 2 plus 3 equals 5. And a nice and easily readable way. The reasons why we would create functions like this are to reuse a lot of the code that we would have normally had to do ourselves. Let's say I wanted to do a whole bunch of adding and printing. Well, instead of doing the addition and writing out this debug log every single time, I can just call this method a couple of times. Add and print, and let's do 5, and comma, 8.
That's like what I see is when you get confusing for me, like why would I put, a comma in there instead of a plus? I see myself doing that already. Like.
Okay. I could see that as confusing when you're first learning it. The comma is right here, and it's hard to tell with the add function. You don't, plus is an operator that adds two things together.
Right.
Comma is actually separating these values into those different integers. Like, as soon as it called this function, that first argument that was passed in is basically saying, use that value that was passed in for int a inside this function.
Right.
And the more you call functions and different things like that.
Getting conditions to it, right?
Yeah. So it's adding more parameters, more data that could be passed in. I can have a whole bunch of different commas and other variable types and things like that passed into this. So if we're doing add and print, let's do one more add and print. And let's say it's going to be 24 and 56. So we'll save that. And I just added these 3 simple lines to start. When I press play, I see a bunch of text actually outputted and formatted correctly, telling me a lot of different information. So that's the reason why we use methods.
So you have to build it once, not 3 different times, right?
Yep, if you notice you're doing something multiple times or repeating code a lot, you typically want to put that into a method. Yes? Okay, one of you guys be able to help? So we'll actually pause real quick. All right, so we're back. Everybody's got that working. Let's move on to some other different functions. So we saw a method that didn't return a value. Let's create one that actually does return a value. because right up until now we've only been using functions that are void returns. So we want to create a function that just adds. So it won't do the printing for us, but it will add two numbers together. So if we are going to return a value, we need to tell it what the return type is, then give this function a name. Well, let's do add. And just like before, we're going to need to take in two different values. Let's do int, and just for the purpose of keeping it separate, I'll say value 1, value 2, and I forgot the type on that second parameter. And now I need a body for the function. You'll notice, unlike that void function, as I was typing it, this one's complaining at me. It's saying not all code paths return a value. Well, it wasn't complaining in void even though it was completely blank, or inside the add and print, because that one wasn't returning anything. This function has to return a value. So what we can do to just appease it in the meantime, we can actually create a temporary integer. Now, defining an integer like this, and we'll call this retval for the return value, is what is called a local variable. It's only going to exist inside this add function. So I couldn't use it inside update, I couldn't use it inside start, unlike how these variables were actually created. When you declare them right in the class, they're what is considered as a member variable. Inside a function, it's considered a local variable. So in order to return that integer value, after we've run our actual code, we can go to the bottom of this function and just say return that retval. And right now it's just saying use of unassigned local variable retval. Well, I never assigned it to anything. Let's assign it right there just to start it off with a value. So a lot of things, like if you see a red line, try and hover over it and it will try and describe to you what that problem is. So if our retval is equal to 0 when this function starts off, we need to actually fill it out with those two values added together. So we can say retval equals value 1 plus value 2. All right, now let's test this actual add function out. So up in our start, we have that add and print. If I do our add, we'll pass it even let's say it's going to be 35, 10. We'll save that. Jump over to Unity. Give that a quick play. And we just see that first add and print actually printing. Well, our other code was actually running and it was returning a value, but we never put it to the screen. So if I wanted to put it into the screen, I need to make sure that I have the debug.log wrapping around that. So now when we go to play, we see that that value was added together. That was 35 plus 10. So that was just showing you two examples of custom created functions, just doing a simple operation on these two things. This one not returning a value and actually printing the number. This one is returning that value but not printing it. All right. Yes, you can make a calculator program. So, arithmetic operators and the order of precedence. What used to be PEMDAS is somewhat PEMDAS without exponent, and it's PEMDAS or PEMDMAS because there's this modulus operator. Modulus returns the remainder of two numbers dividing. So, for example, 10 modulus 3 will actually evaluate to 1. Because 10 divided by 3, it can't go into that many times. There's still a 1 left over. It's very useful for things like finding out if a number is odd or even. It's a very quick way to actually track data for that. We already saw that the parentheses needed to happen. Then comes multiplication, then division, then that modulus operator, then addition, then subtraction. All right. Any questions about the order of operations there? Nope. All right. So we've created two functions. I would like you guys to actually start working on trying to create a subtraction function and a multiplication function. I will also be working on that, but I'm going to pause my screen share so that you guys can work on it on your own. And for those of you that don't know what the multiply operator is for code, it is the asterisk key, which is a shift 8. All right, well, here we're back now, and here's what I've come up with. For sub and print, pretty much copied and pasted the same exact debug log that I had up in that add and print, and just simply change the operator.
That's what I was thinking, yeah.
It is, yep, just as simple as that for simplistic
Purpose,
code. Yeah,
right.
exactly. And multiply print, once again, same exact thing, just a different operator. Let's go ahead and make sure we're testing these out. So we'll need to debug.log these. And we have we don't need a debug.log because I made the print versions on here. We'll do sub and print for subtraction. Takes in two parameters. Let's do 9, comma 3. Then a multiply and print. Oh, crap. Oh, thank you. I enabled it for all the online guys. I'm sorry, I forgot about that one. Yeah. So there's well, I'll show these again for you. So the sub and print, all it's doing is doing a subtraction instead of the addition. I made sure to change the sign that we were actually labeling in here, and the word sum to subtraction. For this one, I have multiplying, and that's going to be returning a product, and it needs to use the asterisk for multiplication. We can then return back to the start and take a look at how we're actually calling these functions. So I have the multiply and print. And multiply and print, let's do, I don't know, 4 and 9. Yeah. Yep. Okay. Let's jump over to Unity and see what those are giving us. So we have this first print, just doing that sum and print of the 2 and 3, which is 5. Second one was just doing that add, which is 35 plus 10. Then we have the subtraction of 9 minus 3 equals 6. Yep. Product of 4 times 9 equals 36. So those all seem to be working. Anybody have any issues coming up with the actual methods for these? Nope. Fantastic. So now we can move on to floating point numbers. So floats I touched base on a little bit last lecture. We'll go a little bit more in depth. Here's a bunch of information inside here. I never wrote a division method because division of an integer by an integer will just return an integer. So what happens if I did 1 divided by 2? Can anybody guess?
If it's a full integer,
if it's an integer,
you wouldn't get it. It wouldn't work, right?
It would run that code, but basically an integer divided by an integer can only return a whole number.
Right.
So what value would the normal mathematic operation of 1 divided by 2 equal?
1?
So it would normally equal 0.5.
Right.
But remember, there's no actual points anywhere. So what the issue with returning an integer is it basically cuts off anything after the decimal point. So it would be 0.
Right,
yep, 0.5. Yep. So that's one of the reasons why we have the floats, and we need floats for certain things that can be partial numbers. So let's go ahead and add a division type, or add a division method. And I'm actually going to copy my multiply and print. So I just highlighted that and pasting it down here with Control V. It's going to complain because it's the same name as the function. So I need to rename this. We're going to be doing divide and print. Instead of product, the division of A, got to change that label real quick, divided by, which is just that /, is equal to a /B. All right. So let's jump up to our start function. And we'll do our divide right here. So let's say it's 5 divided by 1 to start off. We can save that. We'll give that a play. Division of 5 divided by 1 is equal to 5. So it looks like it's all great and dandy. But if we think back to that scenario I was using, I was saying 1 divided by 2 we see that's saying it's 0, when it should be 0.5. And I'll show you what I mean with 5 divided by 2. That should be a 2.5. If we press play now, we see it's saying 5 divided by 2 equals 2. So it's basically just dropping off that decimal point. So that's not a proper function. It's not working correctly how we want it. We need to change the actual types that we're using inside here. Instead of taking in an integer, we need to make sure it's taking in a float for both the values. So this way, when it's doing this mathematical division, it's evaluating to a floating point number.
So then, just curious, like, what would be the? I mean, I guess it's probably simpler than things, but why would you use integers in the first place at all? You know.
So that's actually a decent question. So floats are good for certain things. They have what is called as floating point error. When they start getting certain very precise numbers, like if you have a float, it is almost never equal to 0. It is usually very close to 0.
A huge math problem, and you'll have a million decimal points after it.
Yep. Basically, at around the 9th character or 9th decimal place, it starts losing accuracy, and when you're performing math operations on it, it can actually lose data.
Right. After over the course of like a whole bunch of different processes, yep, it'll lose the whole values, right? Yes.
Floats are also more. They require a lot more compute time than it would with just an integer.
Right. That makes sense.
There's also a lot of things you don't want as floats. Like, for example, if you had your ammo set as floats, and for some reason the designer accidentally added a half of an ammo.
Right.
And all your shooting ammo is subtracting 1, and then all of a sudden you have, like, you're checking if it's greater than 0. Yeah, I have half a bullet. Well, let's shoot one. Boom. It's now negative 0.5 ammo, and it's like, that's wrong.
Okay, so it'll mess up the system.
Exactly.
So, you kind of have to tailor it towards what the purpose is of each one apparently. Like if you know it's going to be a decimal, you should use a.
For example, score, integers, like anything that really doesn't need any of actual accuracy of a fully on floating point variable, you should try and use an int.
Okay.
Yep. All right. So with those, just by changing the parameters that it was taking in, it's now saying float and float. We can give that another test. And we see it's now 2.5. Because a float divided by a float returns a float. All right.
Do they have to match up like that? Does it have to be like float and float, or like could it be like, you know?
I could keep this one as an int.
One's an int and one's a
float. As long as one of them is a float, it will use the floating point math.
Okay.
Which, if I actually hover over this, I see it's using float as the type that it's returning. Because it's whenever you type that slash, it's actually an operator that will use whatever type is passed in that is needed.
Okay.
and it's actually treating both of them as floats.
Seems like it's a lot simpler than it looks, you know, like that.
There's a lot of stuff going on, and it can be very tricky
Yeah.
to actually track down everything, but when you're first learning, it takes a little while. So as soon as I changed both of them to integer, I see it's using the int operator,
Right.
backslash or forward slash. But as long as one of them is a float, it'll treat both of them like floats.
Does that use less computing power, or?
It does. I mean, we're barely scratching the
matter,
surface
right?
right now. You'll be doing hundreds of thousands divisions and pluses per minute or per second, really. So yeah, just try and think of the actual data type you need for the situation.
Right.
All right. And right here is just showing how to do a divide, which we just covered. Any questions about how to declare methods or what the 4 parts of a method are when you're declaring them?
Probably go over it again. Always good to hear it.
All right. So the 4 parts of a method are the return type, which for this one is void. Yeah, getting a partial enemy when you're spawning would be bad. Then you have what is referred to as an identifier or name. And inside these parentheses, you have what is called the parameter list. Then you have the body. So that's for declaring a function or method. Now up here, we're actually calling these functions. So this is a method call. And I'm sorry, I'm going to keep switching back and forth because I was initially trained on function as the term for it. So anytime I say function, it means method. Method call. In here, we just need the identifier, which is that name. And then when you're actually calling this, instead of being a parameter list, it's considered an argument list. Oh, nice. I see what you did there. All right. So that basically brings us to the end of this lecture. If there are no more questions about how methods are working or difference between a method call, method declaration, anything? All right. Cool. I'm going to go ahead and stop the recording then.